All right, good afternoon and welcome to my walkthrough for the Further Maths 2019 VCAA exam. We're starting at Module 1, which is Matrices, and I've got the paper here on me and I can draw what I need to around it. So, first question. Car park has three areas, A, B, and C, empty and full. So the empty car parks are here, the full car parks are here. 1 p.m. on a Friday. What is the order of matrix Q? Remember, it is rows times columns, so it's 3 by 2. Now, if you excuse me, I've 3 by 2. Write a calculation to show that 110 parking spaces are full at 1 p.m. Well, 50 plus 20 plus 40 is 110. Now, they never said you had to write a matrix calculation. However, if you were trying to write a matrix calculation to answer this question, you could have done it with 1, 1, 1, and then 50, 20, 40. And that would have also produced 110 as the answer. You'd have a 1 by 3 times a 3 by 1. Now, the total parking fee is calculated as P by L. What is L going to have to be? Well, if L is a 3 by 1, so it's going to have 3 rows and 1 column, we're going to need to find the numbers that will create that. Well, we come back to this 110 again, and well, we've already got a 3 by 1 matrix here. Well, that's what it is. So if you put in 50, 20, 40, and you multiply that by that, you will get 207. So, the number of whole hours that each of the cars parked was recorded at 1 p.m. Matrix R, you've got there. Now, what they're saying is that they want to... Matrix RT is the transpose of matrix R. So this is where we are going to turn it and we're going to rotate it. But we're going to rotate it in such a way that this here will actually go all the way up to the top right-hand corner. So bottom left becomes top right. So this is a 4 by 3. Well, this new one is actually only going to be a 3 by 4. So what we're going to have is we're going to take this 3, 1, and 1, and we're going to run that down the side like that. We're then going to take this row here, put it next to it, then we are going to keep going. Now, this is one that I know that a lot of my students struggle with. Explain what the element in row 3, column 2 of RT represents. So row 3, column 2. So row 3, column 2 is that one there. we now have to connect that back and write a story about what that 3 is. Well, if we go back to the original, it's that one there. And what you need to actually say is this 3 is the number of cars parked at sea for 2 hours. Right? There's no other way to avoid it. It's not just, oh, it's 3. It's in the context of the information that you're given, what does that 3 represent? Well, you've got the area and the number of hours. Write a sentence that includes that information. Theme park again. The initial state for the attendees in a particular location is there. What percentage of the park's visitors were at Waterworld at 10 a.m. on Saturday? Well, we need to look through here. We need to find out which one's Waterworld. Well, it's that one there. So that's 400. But how many people were in the park in total? Well, that's 6 plus 6 plus 4 plus 4, which is 20. So that's 2,000. Well, if you calculate that out and you get a percentage, you end up with 1/5, which is 20%. So what we've now got is a state matrix, initial state, and a transition matrix, and they want you to complete this using this transition matrix to fill out S1. So we need to take our initial state and we need to take our transition matrix and we need to put them together. So this is where the CAS comes in. So I'm going to, first of all, I'm going to need to create my transition matrix. Again, math 2, 4th row, 3rd column. Create a 4x4. Pop in the information that you need. And odds are we are going to have to use this multiple times. So I would be looking at storing this. As you're going, make sure that you are double checking, make sure that your matrix is correct. I'm going to store that in T. Cool. Yep, that works. Now I'm going to put in my initial state matrix. So it's going to be this one here. That's going to be 600, 600, 400, and 400. I'm going to store that in S. So now what I can do is I can do T times S, and that gets me S1. And then I would simply fill in the numbers that I've got here. Now notice they've given you the 300 already, so you can tell whether or not you've made a mistake. Useful. How generous of them. Next one. Of the 300 visitors expected at Ground World at 11 a.m., what percentage was at either Air World or Food World at 10 a.m.? All right, what percentage of the 300 were at Food World or Air World at 10 a.m. at the start? So we need to go back and we need to look at our transition matrix. So at At G, the 300, Air World was 100, Food World was 1%, 10%, and 20%. So now we need to put that in, and we need to go back and we need to work out, well, okay, so I've got 10% of 600, and then I've got 0.2% of 600. So that's percentage at A, percentage at F. And then I'm going to divide that by the 300 that are there. So therefore, I've got 180 over 300, which is 60%. Now, they want a percentage. So the question says percentage. So you need to make sure that when you answer this, you are also answering in percentage. All right? If you don't answer it in the way they want, they don't give you the mark. All right. The proportion of visitors moving from one location to another on Sunday is different from Saturday. Matrix V shows the proportion. V is similar to matrix T, except the first two rows have been swapped. How do we generate that matrix? So we want to multiply. So this is an example of a permutation matrix where we want to reorder and change the order of some things in here. And to do that, if we think about it, if we think about this as like a identity matrix, if you want to keep everything in a matrix the same, you multiply it by that. So that's an identity matrix. However, if you want to change the order of some things, well, then you can do this instead. So what we're going to do, this one here will keep that row the same. This one here will keep that row the same. But we want to swap these two around. So what I'll do is I'm going to swap these around. And now if I multiply this by T, which I can do because I've got my calculator here. So I've got a 4x4, and I'm going to do this as a test and a demonstration. Times T. Now I'm going to show you P as well, and as you can see here, 3/10, 2/5, 3/5, 3/10, 3/5, 2/5, 3/5, 3/10. I have swapped the order around using that matrix. So, on Sunday, matrix V is used when calculating the number of visitors expected. It is assumed the park will be at its capacity all day. L0 is the state matrix at 10 a.m. And then there are the transition matrix for how things will move around. Safety restrictions require that all 4 locations have a maximum of 600 visitors. Which location is expected to have more than 600 at 11 a.m.? So what they want you to do is they want you to just go V times L0. So what I'm going to do to save myself a little bit of time is I'm actually going to store my transformed matrix in V. So now when I type V, I have that matrix again. And you can even double check it to make sure that it matches up, which it does. And now what I'm going to do is I'm going to put together matrix L, what they've given me here. This is going to be my initial state. So now I can do V times L. Which location is expected? Well, location A which is Airworld. Whenever more than 600 visitors are expected to be at a location, the first 600 get to stay, but everyone else has to move along. State matrix Rn contains the number of visitors at each location after 10 a.m. on a Sunday when the safety restrictions have been enforced. The matrix R1 can be determined from the relationship that we've got there. When matrix B1 shows the required movement of visitors at 11 a.m. Well, how many more did we have than the 600? Well, we had 810. So whatever needs to happen, we need to actually move on 210 people. So to do that, and we need to send them to G. So what we need to do is, we need to subtract 210. We don't need to do anything to F. We need to add 210 to G, and we need to do 0 to W. And then that should give us the answer that we want. And now R2 will now give us a new type of equation. So once we apply the transition, what's going to happen next? Because if we subtract a bunch from one and we do a bunch from another, well, let's put it into the calculator and see what happens. So V times L minus minus 210, 0, 210, and 0. Silly me. No, not minus, plus. So that's the new R1. Well, what we need to do now is we need to put V through this matrix again and see what the new one is at midday. Then figure out how many more we have or how far over we are to then shuffle them along. So we're going to take that matrix there and we're going to multiply that by V. V times ANS. And we get this arrangement here. So we have so many more people in A and W than we're allowed. So what we have to do is we have to figure out, well, how do we get, where do we send all those people? Well, the rules say if you have more than 600 at a location, you move them on to G. So how many more do we have at A and W? So what we're going to do is to this, we're going to now add, well, clearly 786 is 186 over. So that means we're going to have to add 186 here. We don't need to change anything about that one. Now, how many over are we in W? Well, we're 44 over. Now I'm going to go back up and I'm going to put 44 onto that 186, which puts it to 230. Now when I run that, I get R2, which is the answer that we're actually looking for. So that's 600, 288, 512, and 600. And then you would keep going. You would apply the matrix again, but they don't want anything more for this one. This one's finished. Done. Thank you for watching.